Gray, and I'm the team captain and only member of Team Map Quickly. I am located in Niskayuna, New York, which is upstate New York. So I've been a fan of DARPA challenges since the DARPA Robotics Challenge. Participated in that as part of the Lockheed Martin team. Since then, I worked on the NASA Space Robotics Challenge. And following that in 2017, now I decided I wanted to work on DARPA Sub-T. My strategy is motivated by having a one-year-old at home and being a team of one, which is really to take as many open source kind of pre-existing components and see really how well they fit together and the best system I can make going entirely or almost entirely open source. Back in November, December, I attempted to qualify for the urban round. I ended up getting 2 points, but the requirement to qualify at that point was 5 points. And so my system didn't quite make it. No one else qualified that round either. So I'm taking that system that I developed for that, and I've modified it for the cave circuit, and I'm continuing from there. In the previous rounds, I did a lot of experimenting with my localization strategy, and now I believe I figured that out, and so I'm going to focus on really how to get a team of robots to work together and maybe actively partition the space that they're searching. The robots coordinate with each other. I use a Voronoi diagram representation, and then I create a list of frontier nodes from that I share among the robots, and so they figure out how to partition that list of waypoints that they need to visit in real time. So all the ground robots are identical, and all the aerial robots are identical with respect to roles. So the ground robots will move out first, go as far as they can, and anytime that they encounter a place that they need to go, essentially a vertical barrier, they will call in for a UAV to come in and actually start traversing that pathway while the ground robot keeps on going along the available ground routes. So all the robots are sharing a list of objects that have been detected. When one robot finds an object, that information is distributed as wide as possible. And then the robots will also share information about which objects have been successfully reported. And they will just, in the background, continuously be broadcasting this information and attempting to communicate to the beacon at the home base that this object was seen. And then as soon as it's seen, then the robot that successfully reports it will share that information out. I've enjoyed participating in DARPA challenges in the past and will continue to do so in the future. I think that there's a lot of good technology that gets developed and uncovered, discovered through these challenges, and it's just a fantastic thing for DARPA to do.